Hi, everyone. My name is Kevin Schwartz, and I'm a senior solutions architect at AWS. I've been here for 3.5 years with specializations in financial services, IoT, serverless, and resilience. And my background ranges from working at a small startup as a developer and taking on whatever technology tasks needed to get done, through 15 years at a top 4 US bank, designing, building, and leading projects from wealth management client onboarding, broker compensation and finance analytics, and wholesale credit systems across the spectrum of associate-facing tools and customer-facing online portals. So today I'll talk about some trends in financial services and how AWS customers are building to innovate financial service solutions with AWS Serverless. So AWS Serverless helps you build solutions quickly while taking advantage of simplified resiliency strategies. So when we look at the financial services industry, we see a few trends. Banks are closing branches, they're going digital. Capital markets are seeing continued rise in trading volume and volatility. Digital channels are becoming the norm in insurance, and payments are becoming instant and contactless. So all these trends point to the need for technology that can provide resiliency, low latency, real-time data processing capabilities, and easy API connectivity, and the ability to scale rapidly on demand. And so if we dive deeper into one of these trends, payments, let's explore the multiple dimensions of the changing landscape. So payments are growing 4% year over year on average. Macroeconomic conditions can cause payment flows to dip, but they normally grow year over year. They're driven by trade flows, company payments, consumer spending, and overall economics. And I reviewed the earnings transcripts of the top 8 US banks from the 2023 second quarter earnings season that we're in now, and each discussed payments modernization, growth, or investments. Contactless payments have increased. QR codes are used to pay at the table, for example, in airport restaurants when you order, and online shopping has changed consumer behavior quickly. And pandemic responses accelerated what have otherwise occurred in 10 years down to 2 years. So new payment types include instant payments, QR codes, central bank digital currencies. These are a few of the types of payment mechanisms that are either in use or being explored. China launched a digital currency for use in the Olympic Village. 105 countries, or 80% of the world's GDP, are exploring the use of central bank digital currencies, and 10 countries have already fully launched. And we're also seeing the growth of crypto and stable coins in the marketplace. And this modernization is driven by industry changes. So 20 plus market infrastructures are changing payments, messaging formats. It's allowing banks to re-examine and re-architect payment processing. Consider ISO 222 for SWIFT, the clearinghouse, real-time payments, FedNow, and others. And payment data touches today almost every system in the back office with new messaging schemas. So these changes allow banks to redo their systems, processing, and modernize their payments. And integration with market infrastructures such as real-time payments and the European Banking Authority are connecting together to form a cross-border instant payment network. This integration is an example of the future of cross-border payment, but it also demonstrates the desire to have a 24/7 processing and be able to send payments anytime, any day. Another type of integration is embedded payments, where banks and financial service providers are embedding their capabilities into their client sites. And so serverless is a great fit for financial institutions who are ready to modernize their payments infrastructure and systems, or to drive other innovations in areas of financial services. Right, so AWS innovative customers adopts a serverless strategy, and serverless is an area where AWS puts their most investment. And we use our Amazon experience to bake capabilities into these services. The lessons we've learned about building in the cloud, we take the things that are common across all cloud applications and we build them into our services in a way that they completely disappear, so you don't have to think about them, or at least make them as simple as possible to use and control. So there's really 4 key areas where we're always innovating and trying to provide those simple and powerful capabilities. So agility, we want developers and operators to move fast. Performance, support as many workloads as possible. Low costs that follow on-demand usage, and built-in continuously improving security. And the general notion of serverless platforms is that they offer a simplified programming model that completely abstracts infrastructure and application lifecycle tasks to concentrate your developer efforts directly on improving business outcomes. So at the heart of a typical serverless architecture is functions that execute it as code. These functions are launched on invocation and they shut down on completion. That eliminates idle compute capacity. And serverless functions also scale automatically to meet the rate of incoming requests, delivering new level of scaling efficiencies to applications. And in addition to functions as a service, serverless applications are supported by a range of fully managed services. So we have API management, both REST and GraphQL. We have database services, both relational and NoSQL, as well as key value storage. And we have messaging, analytics, streaming data, monitoring, and more. So serverless is purpose-built. It has goals to enable development teams to focus on logic for delivering business applications, features, and services, minimize the amount of staff time required to manage infrastructure and applications, and reduce the impact of application and service outages. So when it comes to resilience, serverless simplifies customer responsibilities. So if you take a moment and you review this AWS shared responsibility model, AWS has responsibility of the cloud. It's shaded here in yellow at the bottom half of the infographic, and the customer responsibilities are shaded in blue in the top half of the infographic. So AWS has got hardware, the global network, and infrastructure. Typically, customers own the design and testing of their architecture, in addition to deployments, observability, managing network quotas, and security configurations. So how do customers approach this implementation, configuration, and operation of applications on AWS, since this resides squarely on the customer side of the shared responsibility model? So to automatically recover from failure, you monitor a workload for key performance indicators, and then you can trigger automation when a threshold is breached. So KPIs should be a measure of your business value, not technical aspects of the operation of a service. And this monitoring allows for notification and tracking of failures, and for automated recovery processes that either work around or repair the failure. And with sophisticated automation, it's possible to actually anticipate and remediate failures before they occur. And when you're testing recovery procedures, in an on-premise environment, testing is often conducted to prove a workload works in a particular scenario. It's not typically used to validate recovery strategies. But in the cloud, you can test how your workload fails, and you can validate your recovery procedures. You can use automation to simulate different failures, recreate scenarios that led to failures in the past. And this approach exposes failure pathways that you can test and fix before a real failure scenario occurs, reducing your risk. And when you're scaling horizontally, the goal is to replace a large resource with multiple small resources, reduce the impact of a single failure on your overall workload. You distribute requests across multiple smaller resources and ensure that they don't share a common point of failure. And stop guessing capacity, because a common failure in on-premise workloads is resource saturation. The demands placed on a workload exceed the capacity of that workload. And this is often also the objective of denial of service attacks. So in the cloud, you monitor demand and workload utilization and automate the addition or removal of resources to maintain the optimal level needed to satisfy demand without over or under provisioning. And you want to manage your change with automation. All of the changes to your infrastructure should be done with automation. And the changes that need to be managed actually include changes to the automation. So then you can track and review those as well. And when we think about the AWS cloud infrastructure, it's designed to help clients meet compliance, security, and resiliency requirements. We start with a region, a physical location in the world where we have multiple availability zones. An availability zone, or AZ, consists of one or more discrete data centers. Each has redundant power, networking, connectivity, and they're housed in separate facilities. Availability zones exist on isolated fault lines, floodplains, networks, electrical grids, to substantially reduce the chance of simultaneous failure. And AZs offer AWS customers an easier and more effective way to design and operate applications and databases, making them more highly available, fault tolerant, and scalable than a traditional data center infrastructure or even a traditional multi-data center infrastructure. And AWS is serving millions of customers in more than 245 countries and territories, and that's continuing to grow. So serverless services are great. They're not only great because you don't need to manage servers or the fact that you're only paying for what you're using, but they come with a ton of pre-built features to make developers and operators' lives much easier. And one of those is built-in availability. So you probably hear this age-old adage, always deploy multi-AZ. Serverless services come with multi-AZ out of the box. You don't even need to configure it. So for serverless disaster tolerance, then we need to start thinking bigger. We need to think about regions. And our documentation, as you go through it for disaster recovery, will cover multiple strategies, but not all of them are suitable for serverless systems. There's really two designs that are most aligned: active-passive or active-active. In active-passive design, it relies on a standby infrastructure. It's created alongside of the main production, though not used unless the primary environment fails. And you could argue that this increases your costs as you need to keep the backup up and running. But the beauty of serverless is you don't pay for anything unless you use it. So it allows you to spin up several backup architectures, even if you choose. A downside to this approach is that failure needs to happen before a failover is initiated. So this creates potential for a temporary downtime, and certain use cases that might not be acceptable. Some it's a good fit. But if you think of like instant payments or financial transactions on the stock market, you can't take the downtime. So the alternative for that is active-active. And on the other hand, this does create additional costs. In this case, we're actively splitting traffic between two environments. And the great thing is if one of them becomes unavailable, the other keeps working. So the traffic flows uninterrupted. The downside, apart from paying for extra resources, is that in this design, your system needs to be idempotent. That means it needs to be able to gracefully handle duplicate messages and data between regions. And you need to keep in mind that these designs do not always need to be specifically built. Some AWS serverless services do offer features that help with automated failovers between regions. So just touching the surface of these features that can help us flip traffic to another environment, let's consider the potential of the most common services in the serverless world. In this example, we're using API gateways, AWS Lambda functions, and DynamoDB tables to create a simple three-tier web application. So at the top, we have our main environment, and at the bottom, our backup that's standing by. The failover in this case is managed by Route 53, which is our domain service. So let's consider this case where a failure is picked up on our primary environment. The flow of our application is synchronous end-to-end, so we can use Route 53 health checks to monitor any issues from the front door. As soon as the health check starts failing and the application moves to an unhealthy state, Route 53 is capable of flicking the switch to reroute the request to the secondary environment. Our data would be replicated through DynamoDB global tables to another region, and the users of our application may experience only a slight delay, if any. And from a management perspective, we need to look after another set of resources, though the backup is really just a replica of the original. So almost all the configuration can be shared between Stack 1 and Stack 3. So to kind of close this out, I'm showing you an architecture that encompasses a holistic view of a buy now, pay later solution. And it's a great example of a reference architecture of a modern payments capability. And what I want to call out in this diagram, as you look through the services used, it has API and microservices with AppSync, API Gateway, Lambda, and Fargate container services. It's secure. It encrypts data in transit and at rest. It has bulk data movement and credit scoring with an AI/ML model. Web metrics are being collected on user behavior, and all of this is with AWS Serverless. That means that you won't take on overhead for patching, provisioning, managing servers, and it simplifies your resiliency architecture. So I hope that you enjoyed learning about how AWS Serverless can help build financial services innovations and meet your resiliency needs while you focus your energy and efforts on your customers and what you're building for them, rather than on the complex and undifferentiated heavy lifting of infrastructure. And when the slides are distributed, I've included some key resources at the end of the deck where you can learn more about serverless, resilience, financial services, and the AWS global infrastructure. So I think we have a minute or so left if there's any questions.